Welcome to our online chemistry class. Our topic is aldehydes, ketones, and carboxylic acid. Let us discuss this topic. So, first we'll discuss carbonyl compounds. So, all are familiar with this word carbonyl. All of you heard this word while discussing the functional group. So, what is carbonyl compounds? The organic compounds containing carbonyl functional group. These compounds are called as carbonyl compound. So dash C double bond O dash, that is carbonyl group, and this type of functional group is present in various compounds of different classes such as aldehydes, ketones, carboxylic acids, esters, amides, acid anhydride, etc. So as we know that oxygen is more electronegative than carbon, so delta negative charge over this oxygen and delta positive charge over this carbon of that carbonyl functional group. Now in this topic we will discuss about the aldehydes and ketones. So what is aldehydes? So there is a difference between these two compounds. The carbonyl group is attached to at least one hydrogen atom or both hydrogen atom. So if there is a at least one hydrogen atom, then that compound is aldehydes. Other may be hydrogen or alkyl or aryl groups. Then such compounds are called as aldehydes. Okay. So what is the functional group? Here we have to write H. So your functional group become dash CHO or dash C double bond O dash H. So that compound is aldehydes. What is the ketones? There is no hydrogen attached to this carbonyl carbon, and both the groups attached to that carbonyl carbons are alkyl or aryl group. They may be same, they may be different. These compounds are called as ketones. So this functional group is called as oxo or carbonyl functional group. Next is the classification of aldehydes, ketones and carboxylic acid. So here first we discuss the classification of aldehydes. So first type is aliphatic aldehydes, and then we will discuss the aromatic aldehydes. So what is the difference between these two compounds that we have to check? So here in this CHO functional group, the carbon is attached to that carbonyl carbon is sp3 hybridized, means the carbon is of alkyl type. So all the alkyl carbons are sp3 hybridides. So because they are obtained from corresponding alkane by removing one hydrogen atom. So your R group of that aldehyde is sp3 hybridized carbon, but C double bond O carbon, which is the carbonyl carbon, is not sp3, it is sp2. So and if there is a hydrogen as a instead of that R, it also be a aldehyde. So first member is formaldehyde. Then if first R group is CH3, that is the first member, so of alkyl group, but second member of aldehyde, so name of this compound is acetaldehyde. Then if there is a C2H5 group, means CH3 CH2 group attached to CHO functional group, then the aldehyde is propanaldehyde. In propanaldehyde there are 3 carbon total. In acetaldehyde 2 carbon. In formaldehyde only 1 carbon. So only formaldehyde contains 2 hydrogen, and remaining all aldehydes they contain 1 hydrogen directly attached to carbonyl carbon, and other group is alkyl groups. So in this case that group is alkyl attached to carbonyl carbon, so the type is aliphatic. If instead of that, if aromatic group is attached to CHO functional group, then that compounds are aromatic aldehyde. So C6H5, this is C6H5 attached to CHO. So parent compound is benzene. So replace the word ene from benzene by the word aldehyde. So benzaldehyde. In this case, this carbon is first carbon and this carbon is second carbon. So the second carbon hydrogen get replaced by OH functional group. So of that benzaldehyde, then the compound is salicylic. And if fourth carbon of benzaldehyde get replaced by NO2 group, then that fourth carbon position is called as para. So para nitrobenzaldehyde. Okay. Then next is classification of ketones. First type is aliphatic ketones and then aromatic ketones. Again, aliphatic ketones can be classified into two subclasses: simple or symmetric ketones and second mixed or unsymmetric ketone. So let us discuss what is aliphatic ketones. So if two identical or same or two different alkyl groups attached to carbonyl carbon, then that ketone is called as aliphatic ketone. So both are alkyl groups. They may be same, they may be different. So it depends on that type of alkyl group attached to carbonyl carbon. This aliphatic ketone further classified into two types. First is simple or symmetric ketone. In this ketone, R and R dash, which is the alkyl group attached to carbonyl carbons, are identical or same. So for example, CH3 CH3 attached to C double bond of carbon. So CH3 means methyl. They are two in number. So dimethyl ketone. It is also known as acetone. If they are C2H5, C2H5 means ethyl, but they are two in number. So diethyl ketone. If these two alkyl groups attached to carbonyl carbon is different, then the ketone is called as mixed or unsymmetric ketone. For example, one is CH3, another is C2H5. So C2H5 is ethyl, CH3 is methyl. Arrange them in alphabetical order: ethyl, methyl, and then follow the word ketone. So ethyl methyl ketone is the mixed ketone. If one is C2H5, another is C3H7. C3H7 is propyl. If all three carbon in the chain, so that group is N-propyl. So consider the P from propyl and not the N, and E from ethyl for arranging them. So ethyl and propyl ketone. Then next one is aromatic ketones. The compound in which carbonyl carbon is attached to either two two aryl or one aryl and one alkyl group. Then that ketone is called as aromatic ketone. At least one aryl group should be present, one or two. So two phenyl groups are attached to C double bond O carbon. So your compound is benzophenone, and these groups are phenyl groups. So diphenyl ketone is also another name. Then if one phenyl and one methyl group is present, alphabetically M first. So methyl phenyl ketone is the name of this compound. Another name is acetophenone. Acetophenone. Now, do you know these compounds? Benzaldehyde has bitter taste and it is bitter almond flavor. All are familiar with vanilla. So vanillin is this compound which has vanilla flavor. Cinnamaldehyde, cinnamon, all are familiar with that. So this compound present in that. All are familiar with camphor, its macrons, and it is also aldehyde type. So all these are aldehyde which are naturally occurring compounds. Next one is classification of carboxylic acid. So again, two types: aliphatic carboxylic acid and aromatic carboxylic acid. So what is aliphatic carboxylic acid? The organic compound in which carboxylic functional group is present in your compound and it is directly attached to an alkyl group, then it is called as aliphatic carboxylic acid or fatty acid. So except formic acid, in that formic acid hydrogen is attached to COH, remaining all carboxylic acid contains alkyl groups. Okay, so in formic acid hydrogen is attached to COH. So HCOOH is formic acid and your remaining are CH3COH is acetic acid, CH3CH2COH propionic acid. Okay, then this aliphatic carboxylic acid further classified into mono, di, tri carboxylic acids. What is the base? Base is number of carboxylic groups present in your molecule. So if one COH is present, mono means single, COH means carboxylic group. So that class is a monocarboxylic acid. Example is all these: acetic acid, formic acid, propionic acid, butyric acid. These are the acid which contain one carboxylic functional group. So they are monocarboxylic acids. If they contain two COH functional group, a dicarboxylic acid, COH, compound name is oxalic acid. If they contain 3 COH, then your class is tricarboxylic acid and this compound is citric acid. So this acid is present in citrus fruit like lemon. So I think all of you understood this classification also. Then next one is aromatic carboxylic acid, the compound in which one or more COH means carboxylic acid functional groups are directly attached to your aromatic ring or basically the benzene ring, or there may be another aromatic compounds that also contain aromatic carboxylic acid. So here we replace the hydrogen from benzene by COH. So name of the compound is benzoic acid. So all are familiar with this. Two COH is present and they are neighboring carbon. So it is phthalic acid. So this is mono carboxylic acid but aromatic type. This is dicarboxylic acid aromatic type. Then acetyl salicylic acid, one COH and one acetyl group, CH3CO group is acetyl group. So this one is acetyl carboxylic acid and another name is aspirin. Then side chain aromatic acids. So if your COH functional group is present on the side chain of your compound but not as a part of your ring, then that compounds are called as side chain aromatic acids. So this is one, and all are familiar with acetic acid. This is acetic acid, CH3COH. We replace one hydrogen from this CH3 group and that replaced by C6H5, that is phenyl. So name of the compound is phenyl acetic acid. Okay, so these compounds are widely distributed in nature like plants or animals. L-lactic acid is present in curd, citric acid is present in citrus fruit like lemon, orange, acetic acid is present in vinegar. So that is the natural occurrence. Then nomenclature of aldehydes, ketones and carboxylic acid. First we discuss nomenclature of aldehydes and carboxylic acid. So if we understood the nomenclature of acid, carboxylic acid, then it is very easy to understand the nomenclature of aldehydes. Okay, trivial means common name. So common names of aliphatic aldehydes are derived from the trivial names of corresponding carboxylic acids. So by simply replacing the word ic acid by the word aldehyde. Okay, and in case of substituted aliphatic carboxylic acid and aldehydes, the positions of that substance indicated by the Greek letters alpha, beta, gamma, delta and omega. We can't use the numbers while writing the common or trivial names. Okay, so I indicated the alpha carbon in this compound. So carbon next to COH functional group. Remember that carbon after functional group is called as alpha carbon. Then so this carbon is alpha carbon, this carbon is alpha carbon. Okay, and next to that is beta. So this is beta, this is beta, and this one is gamma. So this is alpha, this is beta, and this is gamma. Okay, in this way you have tried the numbering. So what is the common names of these acids and corresponding aldehyde? HCOOH, formic acid. So there is no alkyl group, hydrogen is present. So formic acid. So this name comes from word forma, means ant. Latin word is there. So when ant bite you, then it insert one chemical, and that chemical is acid. So that acid is called as formic acid. Forma means ant, that's why the word formic acid. And simply remove an oxygen, then what is your compound? HC double bond OH. So replace the word ic acid by the word aldehyde. So name of the compound is aldehyde. Then CH3COH, acetic acid, acetum is the word for vinegar, and replace the word ic acid, remove an oxygen, then your compound become CH3CHO and compound become acetaldehyde. Then next one is propionic acid, CH3CH2COH, propionic acid. So replace the word ic acid for writing the aldehyde, and for writing the structure remove an oxygen, your compound become CH3CH2CHO. Replace word ic acid, the compound becomes propionaldehyde. Then next one is butyric acid, CH3CH2CH2, total 4 carbon. Okay, in propionic acid total 3 carbon including COH. So in this compound all the alkyl group carbons are in the straight chain. So normal type of compound is there, that's why N-butyric acid. And for writing the aldehyde, replace ic acid by the word aldehyde. Okay, and COH functional group get replaced by CHO by removing one oxygen. So butyraldehyde, and here also all carbon in the straight chain of that alkyl group, so N. Then N-valeric acid, CH3, CH2, 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 3 times CH2, COH. So N-valeric acid, and only change in the functional group. If it is CHO, then aldehyde, replace ic acid by the word aldehyde, N-valeraldehyde. Then IUPAC nomenclature of aldehydes and ketone. First you have to select longest carbon chain containing CHO and COH functional group respectively in your parent chain. Then in aldehyde, the suffix E of the alkane get replaced by Al while writing their IUPAC name. While writing the IUPAC name of acids, replace the word E from alkane by the word OIC acid. Then remember that while writing the numbers, you have to give first number to your functional group CHO or COH, because they are always comes to one end. That carbon is always carbon number 1. If more than one CHO or COH groups are present, then retain the suffix E and using the prefix di, tri before the word Al or OIC acid. Then in alicylic aldehyde, CHO functional group named as carbaldehyde added after the name of cycloalkane, and in alicyclic acid the name cycloalkane carboxylic acid. Okay, then while writing the substituted aromatic or carboxylic acids, aromatic aldehydes and aromatic carboxylic acids, if there are two or more functional groups attached to aromatic ring, the higher priority is given to lower number. Okay, so if CHO group appears as a substance, then use the prefix formyl. Okay, you have to follow the priority order, and that priority sequence is given in 11th standard book under the topic 14. So here is the priority sequence group. First priority is always given to COH, name is carboxy, and to write the name in IUPAC same, last E gets replaced by OIC acid. Then this is ester type, ester functional group, prefix word alkoxy carbonyl, and what is the suffix word dash OATE. This E get replaced by OATE. Then sulfonic acid SO3H group, then COX haloformyl dash OYL halide, then CONH2, this is amide functional group, and carbamoyl amide type, then CHO means formyl, and what is the suffix word AN, cyano and nitrile word respectively for CN functional group. NC means isocyano and isonitrile, this is isocyanate compounds. Keto or oxo is a prefix word, and ONE. Then OH means hydroxy, and the suffix word is OL for alcohol type of compounds. NH2 functional group means amines. Amino is the prefix word and amine is the suffix word. Dash OR means alkoxy group. There is no separate class. Double bond means alkene. No prefix word. Direct suffix word is written ENE. Triple bond YNE. Dash NO2 always use prefix word nitro. No suffix word. Dash X means halo. Chloro Cl, bromo Br, ido I, and R means alkyne. So in this way you have to follow the priority sequence. Let us discuss some compounds. So here one compound is given. Always give one number to functional group. If there are two functional group, check the priority sequence. Here CHO and OH, these two functional groups are present in your compound, but CHO is first in your list, so write down one number to that functional group and four number to your OH. Okay, how to write the numbering? Here you have to write the numbering in clockwise direction, because one another group is present on third carbon, which also gives lowest number in your numbering. So if you write in anti-clockwise, the functional group is present on the same number 1 4, but your alkyl CH3 group is on fifth carbon, so that is not the correct numbering, right? So write down the numbering in clockwise direction. So use prefix word hydroxy for your second priority group and suffix word for first priority group. So 4 hydroxy, alkyl group is methyl on third carbon, so 3 methyl. Your compound parent compound is benzaldehyde. Okay, benzaldehyde. Then this one functional group is COH, another is OH. So first priority is given to this COH functional group, so that carbon is carbon number 1. write down numbering in clockwise. So OH functional group carrying third number and CH3 on fourth carbon. So and use prefix word for OH functional group, 3 hydroxy. On fourth carbon there is alkyl, so 4 methyl, and the parent compound is benzoic acid. Then if CHO and COH functional groups are present, give first priority to COH because it is first member in priority sequence. Then CHO gives 2 number carbon functional group is after the COH. So what is the prefix word for aldehyde? It is formyl. So 2-formyl benzoic acid. So in this way you can write the name. Then the common name and IUPAC name of few compounds. So all familiar with HCOH, formic acid. So how to write the IUPAC name? While writing the IUPAC name, remember that the functional group carbon is also included in your chain. So first number is given to COH carbon, and your compound also only one carbon is present. So one carbon alkane is methane. Replace the word E from alkane by the word OIC acid. So HCOOH is methanoic acid. Then acetic acid contains 2 carbon, one carbon in your functional group, another carbon in alkyl group. So this COH carbon is first, then CH3 is second. So what is the IUPAC name of acetic acid? 2 carbon alkane ethane, replace E by OIC acid, so ethanoic acid. Then in next compound propionic acid, 2 carbon alkyl group is present, it is attached to COH functional group. So 1, 2, 3. So 3 carbon is propane, replace E by OIC acid. So propanoic acid is the IUPAC name of propionic acid. Then in next compound 4 carbon chain, common name means N-butyric acid. Here 4 carbon alkane is butane, replace E by OIC acid, butanoic acid. Okay. Then here in N-butyric acid all carbon in straight chain. So N-butyric acid, and there is no branch, but in this compound, so what is your compound? CH3 twice means 2 CH3 groups are attached to this CH carbon. So what is the compound? CH3 CH CH3 COH. So one branch is present, and that's why one branch is present on second carbon of the chain. So iso compound. So isobutyric acid. How will you write the another name of isobutyric acid? So this functional group carbon, next that is this alpha. Alpha carbon contain one CH3 group as a branch, and second next one is beta carbon is a CH3 carbon. So alpha carbon contain one branch of methyl group. So alpha methyl 3 carbon chain compound is previous this one. So propionic acid. So alpha methyl propionic acid is the another common name of isobutyric acid. When you write the IUPAC name, COH carbon is 1, CH carbon is 2, and CH3 is third, and second carbon contain one branch of CH3 group. So that is CH3 means methyl. So 2 methyl 3 carbon chain propanoic acid. Only the difference of I. Okay. In common name propionic acid, in IUPAC name propanoic acid. So 2 methyl propanoic acid. Then in this compound there is a double bond. Okay. So common name is your compound is CH2 double bond CHCOH. So it is acrylic acid, and while writing the IUPAC name, first number is given to COH 2, 3. So 3 carbon alkane propane. Then there is a double bond on second carbon. So prop dash 2 dash ANE get replaced by ENE, and then the last E of your prop 2 in get replaced by OIC acid, because COH is the first carbon, so there is no need to write the number before OIC acid. So prop-2-enoic acid. Then this is dicarboxylic acid. Oxalic acid is the common name. 2 carbon alkane is ethane, so ethane. Then this is only 2 carbons, so 1 carbon is written to first, another to second, and no third carbon, so there is no need to write the number, and they are 2 in number. COH functional group, so DiOIC acid, so ethane dioic acid. Then while writing the IUPAC name of benzoic acid, now aromatic compounds we have to discuss. So in this case, or that benzoic acid is also known as benzene carboxylic acid, we replace the word ene from benzene, because benzene is the parent compound, by word OIC acid, so your name is benzoic acid. Then in this compound, COH group carbon is first carbon and CH3 is second. So O-toluic acid, so all are familiar with toluene. If there is no COH group, then compound is toluene, and that's why the word is O, means ortho toluic acid. How to write the IUPAC name first and second. So on second carbon there is a CH3 group of that benzaldehyde. So 2-methyl, benzoic acid. So 2-methyl benzoic acid is the IUPAC name. Now from this benzoic acid, second carbon, if OH is present, so that is salicylic acid. How will you write the another name? This OH is present on ortho position of benzoic acid. So ortho hydroxy benzoic acid is another name of salicylic acid as a common name. How to write the IUPAC name? COH carbon is first, OH carbon is second. So write down the prefix word hydroxy, number is 2, so 2-hydroxy, and parent compound is benzoic acid. So 2-hydroxy benzoic acid is the IUPAC name of salicylic acid. Then if there are two functional groups on first and second carbon, the common name is phthalic acid and parent compound is benzene. We replace the hydrogen from benzene from first and second carbon, so 1,2 dicarboxylic acid. So benzene 1,2 dicarboxylic acid is the name. Then while writing it, the last compound is not aromatic because that ring contains 6 carbon, but there is no alternate single and double bond as that of benzoic acid and the derivative of benzoic acid. So it is not benzene ring, it is cyclohexane ring. So your alkyl group becomes cyclohexyl, and that's why the name is cyclohexyl carboxylic acid. Same word is used for IUPAC nomenclature. Then for writing the names of aldehydes, so if you understood the names of acids, it is very easy to write the names of aldehydes. Okay, so common name is very easy. Functional group replace the COH by CHO, and for writing their common names, replace the word IC acid by the word aldehyde. So HCOH is formic acid, and what is HCHO? It is formaldehyde. Then CH3CHO acetaldehyde. Okay, and what is the acid? Acid is CH3COH acetic acid. So replace the word IC acid from the acid by the word aldehyde. So formic acid, formaldehyde, acetic acid, acetaldehyde, and functional group change from COH to CHO. Okay, so now discuss the IUPAC nomenclature. So what is the suffix word for aldehydic functional group? Replace the word E from your alkane by the word Al for aldehyde. So formaldehyde contain one carbon alkane is methane, so methanol. Acetaldehyde contain 2 carbon including CHO carbon, so 2 carbon alkane ethane, ethanol, and CH is always at the end, so that carbon is first carbon. Then here 3 carbons are present. CHO carbon is 1, CH2 is 2, CH3 is 3. So 3 carbon acid is propionic acid. So word is propionaldehyde for aldehyde. And how will you write the IUPAC name? Propane is the pyridalkane. Replace the word E by Al, so propanol. Then 4 carbon aldehyde is butyraldehyde. All alkyl group carbons are in the chain, so you can write N-butyraldehyde. And we'll write the IUPAC name. Butane is the pyridalkane, so replace E by Al, butanol. But in case of isobutyraldehyde branch chain compound, second carbon contain one CH3 branch, so it is alpha methyl propanaldehyde, which is also known as isobutyraldehyde. While writing the IUPAC name, CHO carbon, this CHO carbon is first carbon, CH is second, then CH3 as a branch, and third carbon is also CH3. So second carbon contain CH3 branch, means methyl, so 2 methyl, 3 carbon chain is propane. Replace the word E by Al, so 2 methyl propanol. So in short, from this propanol, this hydrogen gets replaced by CH3, so on second carbon, so 2 methyl propanol. Then the multiple functional group compounds containing one double bond and one CHO, so acrolein. And what is the IUPAC name? 3 carbon compound propane, double bond is present on second carbon, so prop2ene. Replace last E by Al because first carbon contains CHO function. Then CHO, common name is glyoxal oxaldehyde, and 2 carbon is ethane. They are 2 in number, so di, which functional group? Aldehydic, so ethane diol. Then all familiar with benzaldehyde, same word is used, or benzene carbaldehyde is the another IUPAC name. Then orthotolualdehyde, so CHO carbon is first, CH3 is second. So from this benzaldehyde, second carbon hydrogen get replaced by CH3, so 2 methyl benzaldehyde. Then second carbon hydrogen get replaced by OH, so 2 hydroxy benzaldehyde is the IUPAC name of salicylic. So all are familiar with salicylic acid. Here COOH functional group is present, COH. So salicylic acid, the word is salicylic. Then if 2 COH is present, the compound is phthalic acid. This is phthalic acid, and instead of that, if there is a CHO, phthalate, and what is the IUPAC name? Benzene. First second carbon contain 2 aldehydic functional group, so dicarbaldehyde, carboaldehyde. And last one is not aromatic. Your acid is cyclohexyl carboxylic acid. Here aldehyde, cyclohexane aldehyde. Okay, or cyclohexane carbaldehyde is the IUPAC name. Now nomenclature of ketones. Common names. First, you would write the name of alkyl or aryl group. If they are same, then use the word di before that alkyl group. If they are different, arrange them in their alphabetical order and write down that names. So in case of substituted aliphatic ketones, the position of that substituent or branch group indicated by alpha, beta, gamma, delta, and you write alpha for that carbon which is next to C double bond O carbon, that is your functional group carbonyl. While writing the IUPAC name, longest chain carbon containing CO functional group numbered from that end which is closer to your CO functional group carbon. So remember that CO should be present in your longest chain. And how to write the IUPAC name? Name of that alkane in which last E get replaced by word ON. On. In polyfunctional compound, you have to follow the priority sequence from that table. Higher priority functional group gives lowest number, so you have to start the numbering from that end which gives lowest number to the first priority group in your priority sequence table, and then the next numbering. So if your ketonic functional group gives as second priority group, then use the word oxo as a prefix word, and if it has a first priority in your priority sequence, then you can use the word ONA for that ketonic functional group. So let us discuss the nomenclature. So here the compound is CH3CO CH3. So both are CH3 group, they are same. So use the word dimethyl ketone. Another name is acetone. Three carbon compound is present. So propane is the parent alkene. Replace the word E from alkene by the word ONA. Numbering is same to your C double bond O carbon, so there is no need to write the number. So it is always on second carbon. So propane 2-on or propanone is also be written. Then if we observe the next compound in which alkyl groups are different, one is CH3, another is C2H5. So CH3 means methyl, C2H5 means ethyl. Arrange them in their alphabetical order for their common name, ethyl methyl ketone. While writing the IUPAC name, you have to write the numbering from left side. So CH3 is 1, CO is 2, this CH2 is 3, and this CH3 is 4. So your name is butane. Replace E by ONE and write down the numbering. So 2-on. Okay, but it is always present on second carbon, so you can write, or there is no need to write the number. Both way you can write butane 2-on or butanone is also be written. Then in next compound, if three carbon alkyl group is attached to CO and one is CH3, so CH3 means methyl. All this carbon in chain, normal group is present. So N-propyl, so methyl N-propyl ketone. Okay, and total 5 carbon in your compound, so pentane, and you have to write the numbering from left side. That gives lowest number to CO. So pentane 2-on. Replace E by ONE. Write down the number of that position of CO functional group. And if both are ethyl, so use the word diethyl ketone. Here CO group is present on third carbon, so pentane 3-on. Then if other functional group is present, so Br functional group is present, which has higher priority than CO functional group, but we have to write the numbering in that way. We will use lowest number first your CO functional group and then Br. But if we follow the numbering from left side, Br gives lowest number and CO is also gives lowest number. So 1, 2, 3, and from this side 1, 2, 3, and 4. So right hand side numbering is wrong, to follow left side numbering. And while writing the common name, use the letter alpha, beta, gamma, Greek letters, and not the numbers 1, 2, 3, 4. So Br is present on second carbon, so but it is next to your CO, so this is alpha. So alpha bromo, and this CH3CH means it is ethyl group, so ethyl word, and this is N-propyl, so N-propyl ketone. While writing the IUPAC name, write down the numbering 1, 2, 3, 4, 5, 6. So 6 carbon is hexane, CO is present on third carbon, so hexane 3-on, and second carbon contains Br, so 2-bromo hexane 3-on. Now unsaturated ketone, their name is mesetyl oxide. Okay, and how to write the common name, IUPAC name. So you have to write the numbering from right hand side because it gives lowest number to CO. So 1 and 2. Then third carbon contain double bond, fourth contain one CH3 as a branch, and fifth is CH3. So 4 contain CH3, so 4 methyl. Then total 5 carbons, so pentane. But third carbon contain double bond, so replace ANE by ENE, so 3-in. And second contains CO, So 2-O. 4-methyl pent 3 in 2-O. Then this compound contain multiple carbonyl groups, so it don't have common name. So how will you write the IUPAC name? Total 6 carbon in your compound. So you have to write the numbering from left side. Second carbon contains CO. So and fourth also contains CO. So hexane. Then write down the numbers. Don't replace the E. Write down full name of alkane. Then write down the word ONE, but they are 2 in number, so dione, and write down the position. So they are present on 2 and 4th carbon. So hexane 2,4 dione. If there is a one CO means carbonyl and one aldehydic functional group, so ketonic functional group has highest priority, aldehydic functional group has lowest priority, first priority. So use first priority group as, use the word suffix, and higher priority group, second priority group as prefix. So oxo is the prefix word for ketone. So 3-oxobutanol, 3-oxobutanol is the IUPAC name of this ketone. Then if two aryl groups means phenyl group are present attached to CO, so name is diphenyl ketone. It is also known as benzophenone. So same word is used for IUPAC nomenclature. If one aryl, one alkyl group is present, name is methyl phenyl ketone. It is also known as acetophenone. Same word is used for IUPAC name. Okay, so these are the specific words. There is no rule for that. Why it is written? It is used as it is. And next to that is here CO, here Cl, and fourth carbon contains CH3. Dash means CH3. The group is not mentioned, but if one simple dash is present at the end, there is a CH3. So 1, 2, 3, 4. So clockwise numbering is given, and it is not aromatic because there is no alternate single double bond in your ring. So it is second carbon contain chlorine, so 2 chloro. Fourth carbon contain methyl, so 4 methyl, and it is cyclohexanone. So here are some compounds. You can check their nomenclature. I have given the numbering. So fifth contain 2 Br, second contain 2 methyl groups. Dash means CH3, CH3. So 5,5 dibromo. Use the word first letter always capital. So dibromo dash, number and letters are separated by dash, numbers are separated by commas. So and second contain 2 methyl, 2 dimethyl, total 6 carbon. This here is the 6th one, so hexanal. In second compound, say 7 carbon contain, so total there are 10 carbon chain. In this way you have to write the numbering. Okay, so we write the numbering from left side because it gives lowest number to your carbonyl functional group. So and fifth contain 2 methyl, 7 contain ethyl. Alphabetically E comes first, then M. So 7 ethyl, 5 contain 2 methyl. Then total 10 carbon, so decane. Don't remove the E. Third and fourth contain ketonic functional group. So 3, 4 dione. Write down the single word. Don't give the space. Okay. Then this one, this carbon is first, 2, 3, 4, 5. So 5 carbon chain and CHO functional group. So pentanol. Then here CHO functional group is first from clockwise direction. Third and fourth carbon contain methyl. So 3, 4 dimethyl benzaldehyde. This is not aromatic. It is ring is cyclohexane. write down CO, carbon is 1, 2 and this one is 4. So 2,4 dimethyl cyclohexanone. So this is the end of your session. Thank you very much.